Hey guys, I need to talk about some solubility today. This is actually the third time I've tried to record this, so we're going to hope that it works out. For solubility, once again, this is dissolving, so things dissolving, and specifically, we're talking about dissolving in water. We're going to give you a compound of some sort. It's going to be an ionic compound, so you're going to have two ions, a cation that's positive and an anion that's negative. And so you're going to have to separate that compound just kind of mentally. You don't have to actually draw out anything. And you're going to compare the cation and the anion to these two tables that you should have on the paper in front of you. We'll talk about each of these, but once you find either the cation or anion on there, it will tell you whether those are soluble or insoluble. And there's also a column for exceptions. And so that's kind of where things get a little tricky and weird. So we'll just kind of dive in. What you've got to do, your steps are to look at the anion and check your chart to see if it's soluble or insoluble. So you're going to check stuff in that first column. The second column will tell you one way or another. And then the third will tell you if there's any exceptions that are going to flip that solubility rule. So this is your first column or chart, excuse me. In the first column, it's the ion that it gives you. This top row only has the cations. And all of them that are on here are the group 1 metals. It lists them out there for you: lithium, sodium, potassium, rubidium, and cesium. And then the only positive polyatomic ion, ammonium, NH4. And if these are combined with any other anion, doesn't matter what it is, these will always be soluble, no exceptions. Next, we have our anion. These are all polyatomics that are always soluble with no exceptions. Everything else pretty much has some exceptions, so you're going to have to figure out whether or not those apply. That third row, group 17 halogens, those specifically listed there, chlorine, bromine, and iodine, are usually soluble, meaning they will normally dissolve in water, unless they're mixed with Ag, which is silver, Hg, which is mercury, and Pb, which is lead. So if any of those halogens are mixed with any of those three cations, they will become insoluble. And then last row there is the sulfates, SO4, usually soluble. And then you've got 6 exceptions there. Those first 3, calcium, barium, and strontium, are group 2 metals. And then the same 3 that were in the one before, those are some transition metals, and they render it insoluble. So if those are mixed with sulfate, they are insoluble. This other chart, all these are usually insoluble unless those exceptions are met. And most of these exceptions are in the top chart, the group 1 metals and ammonia. So it's those that are always soluble anyway. So this first row, carbonates, sulfites, and phosphates, insoluble unless they're mixed with group 1 metals and ammonia. The second row, hydroxides and oxides, usually insoluble unless the group 1 metals and some of the group 2, calcium, barium, and strontium. Sulfides are usually insoluble unless, once again, the group 1 metals, group 2 metals, all of them, and ammonia. And then the chromates, CrO4s, usually insoluble unless, once again, group 1 metals and ammonia. These are the reasons you're going to need to identify. It's basically the same thing you just did, figuring out whether it is or is not soluble and why. Rule 1 pertains to that first column or first row. The cation is soluble with no exceptions. Rule 2 pertains to that second row. The anion is soluble with no exceptions. And then 3 and 4 pertain to those next 2 rows. Usually soluble, and 3 is the cation is not an exception, and 4 the cation is an exception. And then 5 and 6 relate more to that second table. These are all usually insoluble, and either the cation is not an exception or it is an exception. So you're going to identify solubility with either an S or an I, and then place the number for the reason why. So if it's soluble because of the fourth rule, you'd put S4. So starting in, we have sodium sulfate, Na2SO4. So we got to separate this out. Sodium is by itself, the Na, and SO4 is by itself. So you got to go find in that first column, Na is what you need to look for first, that cation, and lo and behold, it's in the first row. So sodium is right there. It's one of the group 1 metals. And it says it's always soluble with no exception. So we would say it's soluble. You'd write your S and then identify the rule as to why. And this one happens to be rule 1, soluble and there are no exceptions. So you just write an S and a 1. Whew, excuse me, it's late. Next, we have silver and chlorine. I'll tell you, silver is not on that first column anywhere, but chlorine is. Chlorine is in that third row, I believe, with the halogens. So chlorine is right there, normally soluble, unless it's mixed with Ag, Hg, or Pb. This one is mixed with Ag. So if it's usually soluble and the exception is met, that makes it insoluble. And so it's insoluble because the anion, or the anion is usually insoluble, but no, anion is usually soluble, but the cation is an exception. So that happens to be rule 4. Anion is usually soluble, but the cation is an exception. Now we have lead and sulfate. Lead is not on that first column anywhere, but SO4 has its own row. Sulfates, SO4, usually soluble unless it meets one of those exceptions, and this one does. So that's going to deem it insoluble, and this one happens to be the same rule as the last one. Anion is usually soluble, but the cation is an exception. So I4. Now we have ammonia, NH4, and phosphate. And ammonia is in that first row. It's always soluble with no exceptions. So we have soluble ammonia in rule 1, no exceptions. Then we have mercury and iodine. Yours actually says Hg2I2. That is a compound, but this one kind of falls more in line with what we've been doing, so I made it just HGI2. Same thing. It's not going to affect it in any way what we're doing right now. So Hg is not on that first column anywhere, but I is. It's that halogen one. So we find the I, soluble, unless it's mixed with one of these, that it actually is an exception. So this one becomes insoluble. And once again, rule 4, usually soluble, but the cation is an exception. Then we have iron and chlorine. Iron is not on that first column anywhere, but chlorine is on that halogens row once again. Usually soluble unless it's mixed with silver, mercury, or lead. Fe is iron, and it's not any of those 3, so this one is going to stay soluble. And then this one is rule 3. Usually soluble, cation is not an exception. So that's taking you through the rules. You will always have access to this chart. And try to go over here to there we go. Go over here to using solubility rules. This is the one we're going to be using today. Just like always, you get 3 attempts. They'll build on each other. I kind of started this earlier, so I'm just going to pick up where I left off. So you're going to get the chart over here on the left, the solubles and insolubles with the rules as well. So you're going to identify based off of whatever compound is given. I did these first 2 earlier on the video I tried. So let's go with this one. Aluminum, Al, and chlorine. Aluminum is not a group 1. It's not. That's the only cations that are on here. So we're going to have to look for Cl, chlorine. Chlorine is one of these halogens right here. So it is usually soluble unless it's silver, mercury, or lead. Aluminum is none of those. So we're going to stick with soluble And it's because the anion is usually soluble and the cation is not an exception. So you're going to identify solubility and then the rule as to why. And so we'll look at one more. Again, aluminum. We said it wasn't on this first row. Sulfate, SO4, it's got its own row, usually soluble unless it's one of those six. And aluminum, Al, is not one of those six. So this one happens to be the same answer as the last one. Soluble, sorry, because the anion is usually soluble, the cation is not an exception. So that's what you're going to do. There's 15 questions. You get 3 attempts. They will ideally build on each other. So if you do have questions, just let me know. Have a great day, guys.